Have you ever looked up to the sky and asked yourself, how does the universe work? So let me ask you this. Why doesn't the moon fall on Earth? To find the answer, we have to understand the basics of gravity. So let's jump back in time, to the year 6087. On a sunny day, Newton observed an apple falling off a tree. And he came to the conclusion that a force called gravity attracts masses to the center of Earth, which translates to the force that pulls an apple to the ground is the same force which makes the moon orbit Earth. But hold on, that would mean that the moon will eventually crash into Earth, right? But it won't. Why? Why doesn't the moon fall on Earth? A question even Newton couldn't answer. So let's jump to the year of 1908. A young German physicist named Einstein looked at it and knew that our understanding of gravity is not complete yet. And he had a breakthrough. He found out that gravity is not just a force, but a geometric property which describes space-time. I know it sounds complicated, but to put it into simple words, Einstein found out that space and time are basically one thing. Space-time, what once were two different things, now happen to be connected. You can imagine the whole universe as a single fabric of space-time, and heavy masses, like Earth, can warp or curve it. The warping of space-time is what we feel as gravity. Like a bowling ball warps the surface of a trampoline. In 3D space, it would look like this. Do you see how space is curved through masses? Now let's get back to Newton's apple. Imagine you throw an apple. You give it an initial velocity, but gravity is continuously pulling it down. If you throw the apple a little bit faster, it will just take a longer path. The velocity moving forward and gravity pulling it down. Now imagine this. You are in space, outside of Earth's atmosphere. If you throw the apple again with enough speed, the apple will take a much longer path and eventually make a complete circle. The apple, however, will never lose speed, and gravity is pulling the apple to the center of Earth. And that's why the moon is orbiting Earth. Remember the trampoline of warped space-time? In 3D, it would look something like this. The velocity of the moon and Earth's gravity are basically in balance. Earth curves the space around itself, and the moon tries to go as straight as possible in that curved space. We understand all that because of Newton and Einstein. What once started with an apple led to space-time. One of the biggest scientific breakthroughs of humankind. So next time you look up to the sky, ask yourself, why doesn't the moon fall on Earth?